Hello students. Today we are going to continue with exercise 1.5 and then we are moving on to the next exercise. So what we learnt in the last class, we learnt about a complement of a set. What is meant by complement of a set? The elements of U which are not the elements of the set which we are considering. U means universal set. So this concept is related to the universal set. If we need to find the complement of a particular set, we should know what is the universal set. We will compare the given set with the universal set. Leaving all the common elements, we will write the remaining elements of the universal set. That will become the complement of the particular set. This is what we learnt in the previous class. This concept is related to the difference of two sets. A complement is nothing but finding the difference of A with the universal set. That's why we have written A complement as U minus A, and we have seen few properties of the complement, and I have stated what is De Morgan's law. What is De Morgan's law? A union B the whole dash is equals to A dash intersection B dash, and A intersection B the whole dash is equals to A dash union B dash. First one is a De Morgan's law on union, second one is a De Morgan's law on intersection. Right? Now let us continue with exercise 1.5. In exercise 1.5, I gave first two problems as homework. Now we are moving on to the third problem. Taking the set of natural numbers as the universal set, write down the complements of the given sets. The same way they have given you few sets, but instead of roster form, they have given in set builder form, and they asked you to write the complements, right? So first question, set of all x such that x is an even natural number. So the given set contains all even natural numbers, whereas the universal set is the set of all natural numbers. So when you compare the universal set with the given set, what are all the elements will be left out in the universal set? The remaining will be entirely odd numbers, right? So the complement of the first question will be the set of all x such that x is a odd natural number. So if you see the second question, the same way it is given as x is an odd natural number. X is an odd natural number. Therefore, the answer, its complement will be the set of all even natural numbers. Then the third question, a set of all x such that x is a positive multiple of 3. So its complement will be the set of all x such that x is not a multiple of 3. If you write in set builder form itself, that is enough. If you want to express it in roster form, then it will be an infinite set. You should express it with dots, right? Now hope you can do the remaining problems by yourself. Now we will see question number 8. A set of all x such that x plus 5 is equals to. See the 8th question, a set of all x such that x plus 5 is equals to 8. Before finding the complement, we should know what are all the elements are there in that given set. So since it is given as a linear equation, first we will find what is that element. So x plus 5 equal to 8 means x is equals to, bring this 5 to the other side, so it will become 8 minus 5, so x is 3. So the set consists of only the element 3. X is equal to 3. Instead of giving directly x equal to 3, they have given a linear equation. We solved and found out what is, whenever you have a equation or inequality, first solve it and find what are all the elements, right? Now here set of all x such that x is equal to 3. Then its complement will be what? The set of all x such that x is a natural number and x is not equal to 3. Leaving 3, the remaining all elements from the natural number. How do we know this is natural number? Because it is not mentioned in the question, but it is given in the universal set. In the question they have stated universal set is a set of all natural numbers. So when we are finding the complement, we are bothered about the universal set. We will just compare the given set with the universal set, and we will leave the given set and we will write the remaining elements in the universal set, right? So what are the remaining elements in the universal set? They are all natural numbers only. So the complement will be the set of all x such that x belongs to n and x is not equal to 3. Why it is not equal to 3? Because only 3 is available in the given set. So when we are talking about its complement, we should leave that element. So I am leaving 3 and I am writing the remaining elements, right? Now we will see the next question, subdivision 9. The set of all x such that 2x plus 5 is equals to 9. The same way as the 8th problem. So first find, whenever you have an equation, I told you solve it and find what is the value of x, then only you will get a clear idea. So now 2x plus 5 is equals to 9. So bring this 5 to the other side, so it will become 9 minus 5, which is 4. Bring this 2 to the other side, it is under multiplication. If you bring it to the other side, it will become division. So x is equals to 2. So the set consists of only 2. Therefore its complement will be the set of all x belongs to n, and x is not equal to 2, right? Now see the next question, it's an inequality. Set of all x such that x is greater than or equal to 7. So its complement will be set of all x such that x is a natural number and x should be less than 7. Here greater than or equal to, which means all the numbers greater than 7 and including 7 will fall under this set, because they have given equal to sign. So when its complement will be less than 7, you should not include 7. And see the next question, set of all x such that x belongs to n and 2x plus 1 is greater than 10. Here directly they have given the range of x. Here they have given an inequality. So find what is x, what is the range of x, and then write its complement. So again the same way, 2x plus 1 is greater than 10. Bring this 1 to the other side. So 10 minus 1, 10 minus 1 will be 9. So 2x is greater than 9. So x will be greater than 9 by 2. Bring this 2 to the other side. So we found out the range of x. X is greater than 9 by 2. So its complement will be greater than, opposite on the less than. So less than. Here equal to sign is not there. So you have to add equal to sign. So x is greater than 9 by 2. Its complement will be x less than or equal to 9 by 2, where x is a natural number. Understood? So next question. They have given you as 1 to 9 numbers, set A, set B elements they have given. They asked you to verify A union B the whole dash is equals to A dash intersection B dash. What law is this? This is De Morgan's law, right? So they asked you to verify De Morgan's law numerically. Numerically verifying is easy only. First take left hand side, find 1 by 1, and then take right hand side, find 1 by 1 and check whether both are equal or not. First I am going to take a left hand side. Left hand side what we have, A union B the whole dash. Directly we don't want to find, we will find step by step. First find what is A union B. What is A union B? Union operation means it includes all the elements of A as well as the B. So write all the elements of A and then the elements of B, leaving the repeated elements. So first list out the elements of A, 2, 4, 6, 8. Then write the elements of B, 2. But 2 we have already listed out, so leave it. Then 3, then 5 and 7. So this is A union B. Now we need to find A union B the whole dash, which means for this set we need to find the complement. Complement means what? Compare this set with the universal set and leave all the elements which is available in A union B and write the remaining elements of U, right? So first check 1. 1 is not there in A union B. So I should write 1. 2 is here. 3 is here. 4 is also there. 5 is also there. 6 is also there. 7 is there. 8 is there. 9 is not there. So A union B the whole dash is nothing but 1, 9. This is our left hand side. Now we need to find our right hand side and check whether both are equal. Now we are going to find our right hand side. Right hand side, A dash intersection B dash. First we will find what is our A dash. The set A has elements 2, 4, 6, 8 and universal set has elements 1 to 9. So what A dash will have, again compare these two sets. 1 is not there in A. So A dash will have 1. Then 2 is there. 3 is not there. So A dash will have 3. Then 4 is there. 5 is not there. So A dash will have. Now see, A dash is the elements which is not there in A, right? So 1 is not there, I have listed out. 3 is not there, then 5. 6 is there, then 7 is not there, so I have written 7. 8 is there and 9 is not there, so I have written 9. So A dash is 1, 3, 5, 7, 9. Similarly, how you will find out B dash? B dash is the elements which is not there in B but is available in U. B has 2, 3, 5, 7. So the remaining elements 1, 4, 6, 8, 9 I have listed out. Now we need to find the intersection of A dash and B dash. So intersection means what? Common elements. The elements which is common in A dash and B dash. Which is common in A dash and B dash? See, 1 and 9. The remaining elements are different. So A dash intersection B dash is nothing but 1 and 9. So when you check out the left hand side, A union B the whole dash is also 1 comma 9 and A dash intersection B dash is also 1 comma 9. Therefore left hand side is equals to right hand side and hence we verified the De Morgan's law. Similarly we can find the or verify the other De Morgan's law even, right? See, next question is drawing Venn diagram. They have listed out few questions and they asked you to draw appropriate Venn diagram. So first question is A union B the whole dash. So how we can draw? As I told you, step by step we can draw the Venn diagram. So first draw the Venn diagram for A union B and then draw for its complement. So first step what we will do? First we will draw a rectangle and since it involves only two sets, draw two circles alone. And even this also I insisted on, unless and until they mention about the sets, whether it is disjoint set or one set is a subset of the other, you go for the overlapping of sets only. So this is A and this is B and this is your universals. Now we are going to draw what is A union B. What is A union B? The entire region of A and the entire region of B. This is your A union B. Then what will be A union B the whole dash? Again draw a rectangle, two circles A, B and this is your U. Now we are going to find A union B the whole dash, which means compare this diagram with the universal set. Leave the region of A union B and shade the remaining region of the universal set. That's what the concept behind complement, right? What is the concept behind complement? We will compare the set with the universal set. Leaving the elements of the set, we will write the remaining elements of the universal set. That's what the concept behind complement of a set. The same way here, compare the shaded region with the universal set. Leave the shaded region. Why we shaded here? Because this denotes the union. We need its complement. So leave this shaded region and shade the remaining region of the universal set. Which is our universal set? The rectangle is our universal set. So the remaining region means this region will be A union B the whole dash. Right? Now what is your second question? A dash intersection B dash. Similarly, we will do it step by step. First, we will find what is our A dash. Again, draw a rectangle, two circles. This is your A, this is your B, and now we are going to draw what is our A dash. Since we are going to find only A dash, don't draw only single circle because the entire question is related with two sets. So, for each and every step, you should draw only two circles, right? Now we are going to find what is our A dash. A dash means what? Leaving the region of A, we should shade the remaining regions of U. So leaving A, we are going to shade the remaining region of U. And B is also there in B, U only, right? So the region of B also should be shaded. This is only our A. So leaving A, the remaining things should be shaded, right? Similarly, next step we are going to find what is our B dash. A, B, and now we are going to find what is our B dash. B dash means you should leave B alone. You should leave B and then you should shade the remaining regions. right? This is our A dash and this is our B dash. Next, what we need to do? A dash intersection B dash. In the sense, which is commonly shaded in both the things should be shaded in A dash intersection B dash. So the third step, we are drawing two circles. This is A, B universal set, A dash intersection B dash. Compare these two diagrams and check out which region is commonly shaded. Which region is commonly shaded? Only the outside region of universal set. Because if you see the first diagram, this outside region is shaded along with B. Here the outside region is shaded along with A. Now which is shaded in both the diagrams? Only the outer region. Outer region is commonly shaded in both the diagrams. That is only will come under intersection part. So A dash intersection B dash is nothing but this outer region only, right? This is only A dash intersection B dash, right? And this is how you need to express the given question using Venn diagram. And if you see the first question, it is A union B the whole dash, and if you see the second question, it is A dash intersection B dash. Both should be equal because this is stated by De Morgan. This is first De Morgan's law. First, what is first De Morgan's law? A union B the whole dash is A dash intersection B dash. And if you check out the answers, both are same. So this how we can prove De Morgan's law using Venn diagram. I told you in the previous class we can prove De Morgan's law using Venn diagram. So this is how you can prove. So here they have asked two separate questions. They may ask a single question like prove De Morgan's law using Venn diagram. The last question we proved De Morgan's law using numerical values. They may even ask prove De Morgan's law using Venn diagram. In that case, you should prove like this. Take your right hand side, left hand side separately, draw step by step Venn diagrams and check whether both are equal or not. Okay. Similarly, you can solve the remaining two subdivisions of the fifth question. Now look at the sixth question, it's quite interesting. Let U be the set of all triangles in a plane. If A is the set of all triangles with at least one angle different from 60 degree, what is A dash? So what does it mean? Universal set is set of all types of triangles. We have different types of triangles, right? So set U has all types of triangles. And the given set consists of all triangles with at least one angle is different from 60 degree. If one angle is different from 60 degree, then it will contain the other types of triangle except equilateral triangle. Yes, only in equilateral triangle all the three angles are 60 degree. Other than equilateral triangle, in the remaining triangles, at least one angle may be different from 60 degree. If all the three angles are equal to 60 degree, it is nothing but equilateral triangle. So what is A dash? A dash will have only set of all equilateral triangles. Hope you understood. Yes. Seventh question in the exercise is fill in the blanks. Hope you can do it. Now before we get into the next exercise, practical problems involving these operations, I wish to list out a few important results related to cardinal number of sets. So what is meant by cardinal number of sets? Cardinal number means the number of elements in that particular set. Cardinal number means the number of elements in that particular set, right? So cardinal number we can have only for finite set, and you should remember all these results. These are all not new to you actually. We know all these results and we are applying for the cardinal numbers. That's it. So only if you remember all these things, you can solve the problems instantly, or else for each and every problem you should sit and think every time. So by heart all these problems, or if you are good in logical thinking, understand it and keep it in your mind, so that only you can solve the problems easily. So first one, let A, B, C be finite sets, and these results are only for finite sets, and obviously because cardinal numbers are meant for only for finite set. Cardinal number means the number of elements in the set, right? Yes. Let us see the first result, n of. How will you read this? N of. N of means the number of elements, right? So n of A union B, which means the number of elements in A union B, which is equals to n of A plus n of B minus n of A intersection B. If you think for a while, you can understand it easily. What we will do in A union B operation, we will write all the elements of B, we will write all the elements of B, all the elements of A as well as all the elements of B, leaving the common elements, in the sense leaving the repeating elements. So how many elements will be there in A union B? The number of elements in A plus the number of elements in B minus the common number of elements. We won't write it once again, right? So that's why number of elements in A union B is equals to n of A plus n of B minus n of A intersection B. The second result is n of A union B is equal to n of A plus n of B if A intersection B is empty, because there can be cases where we don't have any common elements. If the intersection is empty, we won't have this number at all. So it will be just n of A plus n of B. The third result is just the extension of A union B for 3 sets. N of A union B union C is n of A plus n of B plus n of C. You should subtract the intersection mutually with two sets. Minus n of A intersection B, B intersection C, A intersection C, and then you should add the number of elements in A intersection B intersection C. All the three sets intersection you should add, right? Next, fourth result, n of A minus B. N of A minus B is nothing but n of A minus n of A intersection B. Why this is n of A minus n of A intersection B? I think you will get the answer. See, A minus B means what we will do? We will compare the sets A and B, leaving the common elements. Leaving the common elements, we will write the remaining elements of A. So first it is nothing but the number of elements in A, leaving, so minus number of elements in A intersection B, which has common elements in B, right? We will leave those elements. So first we will concentrate on the number of elements in A. We will list out the elements of A, leaving the intersection elements. So that's why it is n of A minus n of A intersection B, which can be restated as n of A intersection B dash. Why this is A intersection B dash? B dash means what we will do? The elements which is not there in B we will write, and if we find the intersection with A, we will get A minus B. If you want, we will check out with one example. Say U is equals to 1, 2, 3, 4, and if A has 1 and 2 and B has 2, 3, 4. Now what will be B dash? B dash will be 1, right? Now what is A intersection B dash? A intersection B dash, A and B dash, which is nothing but 1, right? Now let us find out what is A minus B. A minus B is comparing these two elements. These two sets, we will write the remaining elements in A, which is nothing but A. Therefore, A minus B is same as A intersection B dash. So the number of A minus B is same as A intersection B dash. Therefore, the number of elements in A minus B will be same as the number of elements in A intersection B dash. Next result is number of elements in A dash. N of A dash is nothing but n of U minus n of A. This operation also we have learnt. I told you the complement of a set is nothing but the difference between the universal set and the set itself. So the same result we are applying for number of elements. So number of elements in A complement will be nothing but the number of elements in universal set minus the number of elements in A. And when we are talking about number of elements in universal set should also be finite. So these results are applicable only for the finite results, right? The next two results, n of A dash union B dash is equals to n of U minus n of A intersection B. What is this? This is nothing but De Morgan's law only. What is A dash union B dash? A dash union B dash is A intersection B the whole dash, right? What is A dash A dash union B dash is nothing but A intersection B the whole dash. This is what De Morgan's law, right? This is what De Morgan's law. Now here we are applying it for number of elements. So number of elements in A dash union B dash is nothing but number of The elements in A dash, A intersection B the whole dash. But A intersection B the whole dash complement is nothing but comparing the set with the universal set, the difference of the set with the universal set. So the difference of the set with the universal set, A intersection B the whole dash, I can write it as U minus A intersection B, right? As we written for one set here. N of A dash is nothing but N of U minus N of A. The same way here, N of A intersection B the whole dash is nothing but N of U minus N of A intersection B. This is nothing but De Morgan's law. I repeat, N of A dash union B dash is N of U minus N of A intersection B. How we got this result? By De Morgan's law. What De Morgan told you? A dash union B dash is nothing but A intersection B the whole dash. A intersection B the whole dash. Now A intersection B the whole dash is the complement of the intersection set. The complement of the intersection set is nothing but the difference between the universal set and the intersection of the sets. So N of U minus N of A intersection B. Similarly, the another De Morgan's law. N of A dash intersection B dash is nothing but N of U minus N of A union B. Because De Morgan's law says that A dash intersection B dash is nothing but A union B the whole dash, which means the difference between the universal set and the set, right? So we have seen 7 results now, which is very important to solve the remaining problems in the next exercise. So learn all these results again and again, by heart it. Only if you know it very well we can solve the remaining problem. These are all results based on cardinal numbers and nothing new in this. All these concepts we have learnt previously. We are just applying or extending it for the cardinal numbers. That's it. So do these problems as homework from exercise 1.5, the remaining problems, and learn these important results on cardinal numbers. Only if you know these results we can proceed with the next exercise. So with the next class we will wind up the chapter. So only if you know these results we can proceed with the problem. So learn the results properly. Thank you, students.